Hello everybody and welcome. Alright, we're going to be continuing our chapter on quadrilaterals, or actually we've been talking about polygons so far in this chapter in section 8.1, but now we're going to begin focusing for the rest of the chapter on four-sided polygons, or quadrilaterals specifically. And for the next two sections, 8.2 and 8.3, we're even going to narrow the focus a little bit more and focus solely on parallelograms. In this section, we're going to be learning properties of parallelograms and seeing how you can use those to find unknown measures, and those properties will include properties about sides of parallelograms, properties about angles of parallelograms, and properties about the diagonals of parallelograms. And then in the next section, we'll learn how to determine whether a figure is a parallelogram or not using the same properties that we're going to learn right here. Okay, so let's take a look then. First of all, we're going to go through and kind of list the properties about the sides, then the properties about the angles, and then the properties about the diagonals of the parallelograms. Then we'll go through a series of examples where you apply each of those properties. All right, now I want to start off with the properties about the sides of parallelograms, and the properties about the sides of the parallelograms happen to be properties about the opposite sides of parallelograms. Now, one of them, I hope, is fairly obvious just based on the name parallelogram. All right. One thing that you know about the opposite sides of parallelograms is that they are parallel to each other. So there's the first property. So in this diagram then, we can say that segment JK is parallel to its opposite side, segment ML. And we can say that segment JM is parallel to its opposite side, KL. Alright, that you had to have known before, I'm sure. That's based on the definition of parallelogram. And then something that happens whenever you have two pairs of opposite sides that are parallel like that is that the opposite sides end up being congruent to one another as well. All right, now I won't go through an entire proof for you or anything as to why that has to happen. What I will do is a brief description of why the opposite sides have to be congruent if they're parallel to one another. Let me draw this real quick. Whenever you make a diagonal of a parallelogram, it turns out that since the opposite sides are parallel to one another, you end up with two congruent triangles. And why are the triangles congruent? Well, you have these alternate interior angles there that are congruent to one another, right? You have these alternate interior angles that are congruent to one another, and then you would have this side that is congruent to itself. All right. Now keep in mind the alternate interior angles are only congruent because these lines are parallel and because these lines are parallel. But by angle side angle, the two triangles that I've formed are congruent, which makes the corresponding parts of those sides congruent to one another as well. Anyway, second property about the sides of parallelograms is that they are congruent to one another. So in this picture, we could say that segment JK is congruent to. Now when we start talking about congruent statements, we want to get the corresponding parts in order. And if you think about the fact that these triangles are rotations of one another, you would actually say that J is congruent to, corresponds with L, and K corresponds with M. So segment JK is congruent to segment LM. And then segment JM is congruent to segment LK. All right, easy enough, right? Now let's talk about the properties about the angles of parallelograms. And we're focusing on the interior angles only. You've learned what you need to know about exterior angles of polygons, period. The opposite interior angles of parallelograms happen to be congruent to one another. Now I'm going to illustrate these properties by making up measures. All right, and it wouldn't matter what measures I make up, these two properties that we're going to learn would be true. So let's suppose that this angle J right here is 100 degrees. Now, remembering that the opposite sides are parallel to one another, if angle J was 100 degrees, I'll tell you what, that looks like an obtuse angle or an acute angle. Let me say instead that angle M is 100 degrees. That looks more obtuse, right? Not that they have to look right. But anyway, since segments JK and ML are parallel, then these two angles right here would have to be, well, what would they have to be? They'd have to be supplementary to one another, right? So actually that goes along with the second property that I wanted you. Alright, and I just basically explained that, and that's kind of in the process of explaining why the opposite angles are congruent to one another. Alright, now we just said the angle M, if it was 100 degrees, had to be supplementary to angle J, so that would make that 80 degrees because of the consecutive interior angles here of these two parallel lines and the transversal JM. Alright, now similarly, since angle M is 100 degrees, if you look at the other two pairs of parallel lines, JM and KL, their consecutive interior angles, M and L, would have to be supplementary as well, so that would make angle L 80 degrees as well. Now, do you see why that means that the angles J and L would have to be congruent to one another? Alright, and as far as M and K, they would have to be congruent to each other as well. Couple ways of justifying that. Here's the way I'll go this time. So far we've got 180, we've got 260 degrees in this quadrilateral, and you know from the last section that we did that there are 360 degrees in quadrilateral, so the remaining 100 degrees would have to go right there. So yeah, these two angles are congruent as well. Both pairs of opposite angles are always congruent, and all the pairs of consecutive angles are always supplementary in parallelograms. Alright, so let's solve for some problems involving that. The properties about the sides and properties about the angles. Here I'm telling you to find the value of each variable in the parallelogram, and so the directions are telling you that it's a parallelogram, meaning of course opposite sides here are all parallel to one another. Let's go about finding the variables involving the side lengths first. You notice that you've got three sides here that each have an x in the representation of their side lengths and one that has a y. Well, we want to compare two sides that both have an x to begin with, and of course we know with sides that the opposite sides are congruent. That's the only thing we can really use with the measurements that I've given to you right here. So let's use this equation here. Let's say that 4 times x minus 3 is equal to 3x minus 1, right? This side and this side are opposite from one another, and it's a parallelogram. They've got to be congruent to one another. So we'll get 4x minus 12 equals 3x minus 1, which is going to mean that x is equal to 11, right? Okay, so then how do we go about finding the value of y? Because there's only one side here, or only one measurement period that has a y in it. Well, these two sides are opposite from one another, so we could say that y minus 5 equals x plus 16, and since we now know the value of x is 11, that means we could say y minus 5 is equal to 27, so y is equal to 32. Alright, so there you go. Now let's worry about the angle measures here. I've given you 3 of the 4 angle measures of this parallelogram, or at least expressions for them. 2 of them have m's, right here and right there. The other one has an n. We need to make an equation with the 2 that have m's in them. Now those are the consecutive angles of a parallelogram, so we know that they are supplementary to one another. Let's go ahead and make the equation that says they're supplementary. We'll say 7m minus 26 plus 4m plus 8 is equal to 180. Now collect your like terms on the left side. There's nothing to do with in the parentheses, is there? 7m plus 4m is 11m. Minus 26 plus 8 is minus 18. So we'll get 11m equals 198. And then 11 goes into 198 18 times. Now how about for the value of n? Well, in order to find the value of n, we're going to have to use the fact that the opposite angles of a parallelogram are congruent, right? This angle and this angle would have to be congruent. And we can say then that 5n is equal to 4m plus 8. And since we know that m is 18, that means 5n equals 4 times 18 plus 8. That's 72 plus 8, or 80. So 5n equals 80. And n then would be equal to 16. So that's how you use the fact that the opposite sides are congruent, that the fact that the opposite angles are congruent, and that the consecutive angles are supplementary within a parallelogram. All right, let's continue on. There's also properties you need to know about diagonals of a parallelogram. And simply, what you need to know about the diagonals of the parallelogram is that they bisect each other. Which can be stated several ways with this picture. One thing that it would mean directly if the diagonals bisect each other in this picture is that I can say segment JQ is congruent to segment LQ. All right, these two are congruent because it would have been cut in half, that diagonal. And then the other diagonal would have been cut in half as well because they bisect each other, right? So segment MQ is congruent to segment KQ. Now, another way you can kind of state both those things is that whenever the two diagonals of a parallelogram bisect each other, their point of intersection is the midpoint of each diagonal. So I can say Q is the midpoint of segment JL and segment MK. All right, easy enough. Let's do a quick problem involving the diagonals of a parallelogram. And again, we're finding the values of each variables, very similar setup to what I had before in terms of the strategies used. I've given you the links of each of the 4 segments created when the diagonals bisect each other. And according to what we just learned, these 2 segments would have to be congruent, and these 2 segments would have to be congruent. Well, we can't do much yet with saying that 1/2 p is equal to q plus 2 because we don't know p, we don't know q. But we can do quite a lot with the fact that p minus 3 would have to be equal to 17. So we'll find the value of p first. And that's going to be 20. And now it helps us to say that 1/2 p is equal to q plus 2. Because we can substitute our value of p in and get 1/2 times 20 equals q plus 2. And so that means 10 equals q plus 2. And q is equal to 8. Very simple, right? All right, so now we're just going to go through a series of other problems involving either the sides or the angles. Turns out none of them use diagonals. Well, not directly anyway. Anyway, sides and angles and their properties in parallelograms. All right, here I'm telling you that in parallelogram ABCD, the distance from C to D is 26 centimeters, and the perimeter of ABCD is 84 centimeters. All right, and we're going to find the distance from A to D. Now, one thing I want you to notice is notation here. I didn't mention this earlier, but I should have. This little symbol right here can be used whenever you're naming a parallelogram to indicate that it is a parallelogram. Kind of like you're used to using this symbol to represent that there's a triangle DEF, for instance. All right, you could use this symbol right here to represent that you had a parallelogram DEFG, for instance. It's the only quadrilateral that has such a symbol, but it's worth noting that that's the case. So the directions do tell you that we have a parallelogram. Now, we're going to need to create a picture here. And I need to teach you something about the way you name the vertices and actually name a parallelogram. Let's just go ahead and sketch a parallelogram best we can. Okay, now if I have a parallelogram ABCD, it doesn't really matter which side or which vertex I call A or B or C or D to begin. Let's just say I pick this one as A, B, C, or D. I'll pick it as A. And the important thing after that is that you have to go either clockwise or counterclockwise when you're naming the points. Never skip across. So if I call this point A, it's okay to call either this B or this B, but never the opposite vertex, because I want to be able to say this A, B, C, D, so A, B, C, D. Hopefully that makes some sense. It adds some standardization to the naming. All right, and it's telling us that CD is 26 centimeters. That should be a 6. And that the perimeter for the entire thing is 84 centimeters. All right, so how can we use that to find the distance AD? Well, let's mark that distance AD as x centimeters. And how do you think you'd find the perimeter? Well, the opposite sides are congruent to one another, right? So these two are congruent and these two are congruent. Meaning then I can call this side 26 as well. And I could call this side x as well. And so the perimeter would be equal to 2 times 26 plus 2 times x, right? That'll tally up the total for the 4 sides. And we know that the perimeter here is 84, so we'll substitute that in place of p, and then we can solve for x. We'll get 84 is equal to 52 plus 2x. 84 minus 52 is 32, so 32 equals 2x and x equals 16. And we set it up so that x was equal to in length to AD, so that means AD is equal to 16 centimeters. There you go, nice use of the opposite sides being congruent to one another. All right, now let's look at something dealing with the angle measures. Here it says in parallelogram PQRS, the measure of angle P is 10 degrees more than 3 times the measure of angle S. And we're going to find the measure of each angle of that parallelogram. All right, well, again, we ought to start off with drawing a parallelogram, so let's do that. And pick any side and call it P, and either go counterclockwise or clockwise. I'm going to go counterclockwise this time, and name the angles in the order that they're listed. Okay, now the measure of angle P is 10 degrees more than the measure, 3 times the measure of angle S. All right, I might have named these different if I'd paid more attention to that, but this is fine. If I then call the measure of angle S x degrees, in order to show that angle P is 10 degrees more than 3 times that measure, I would need to say I multiply x by 3, and then I add 10. Make sense? Now another thing, if you hadn't named the parallelogram correctly as far as going clockwise or counterclockwise, you would have had possibly P and S being opposite angles when they're supposed to be consecutive angles. We know that consecutive angles are supposed to be supplementary, so the way we'll solve this is we'll make 3x plus 10 plus x equal to 180. Make sense? All right, now I'd prefer for you to go ahead and pause the video, solve this on your own, find the measures of all 4 angles, because it says find the measure of each angle. But if you need to just keep watching, that's fine as well. All right, so we'll get 4x plus 10 is equal to 180. And the negative is 4x equals 170. And I'll use decimals here. That means x will be 42.5. And as soon as you know the value of x, you know the measure of all the angles. We can say that the measure of angle S is equal to the measure of angle Q, right? These opposite angles had to be congruent, and they're both going to equal 42.5 degrees. And the measure of angle P equals the measure of its opposite angle R, and they're both going to be 3 times 42.5 plus 10. And so that'll give you 137.5 degrees. All right, great. Got one more example here. It's kind of a challenge question involving angles within parallelograms. And it's a challenge question because I'm asking you to find angles whenever you draw the diagonals of the parallelogram. Now, I have no use here for the fact that the diagonals are bisecting one another because I haven't given you any distances. We're only focusing on the angle measures involved. All right? And the basic idea, as you try to go through this, hopefully you're going to try it on your own after you listen to my brief explanation. The basic idea is you're going to take advantage of the fact that the opposite sides of the parallelogram are parallel to one another. And as such, they're going to form alternate interior angles that are congruent whenever you draw diagonals, right? So, if that introduction to this problem is enough for you to solve it, then pause the video, solve it, and then just watch here in a minute as I confirm your answers, hopefully, because hopefully you'll get them right. But if not, just listen. If you're not sure what to do, just keep listening, and I'll explain what we're going to go through here. All right, we're going to start with finding the measure of angle ZWP. And the measure of angle ZWP, well, that would be this angle right here. All right, this is the one we're trying to find. Now, how would we find that? Well, turns out we know its alternate interior angle. See, since WZ and XY are congruent, this angle is 22 degrees. That's going to make this angle 22 degrees as well. All right, right there and right there. So that's 22 degrees. Now, how about the measure of angle WXY? All right, so that's this angle right there. Or if we just look at the whole thing, right there. Now, how are we going to go about finding that? Well, if you go a little bit further with the measurement we just found, what we just ended up doing essentially was finding out what the measure of angle ZWX is, because now we know the two angles here and here that make up that angle. Now, notice they weren't congruent. The diagonals don't have to bisect the opposite angles in a parallelogram. But now we know that this angle is 63 degrees, right? And we know that the consecutive angles, as angles W and X are, have to be supplementary to one another. So we're going to do 180 minus 63, and that's going to tell us that this is 117 degrees right there. That's the measure of angle WXY. All right, just two more to go. I know we're getting a little bit lengthy in time here, but this is very valuable to you. All right, the measure of angle ZXY. So here's angle ZXY right there. I'm just going to pick a different color for it. Let's use blue. There we go. How would we find that? Well, we can't just cut that 117 degree angle in half, which would be your first instinct. Just doesn't work that way. But we can take advantage of this triangle PXY. The fact that we know two of its angle measures means we can add up the 85 and the 22 and subtract from 180 to find out what the third angle measure is. And that third angle measure then would be 73 degrees. All right, and then finally, we're going to find the measure of angle XZY. Let's see what other colors I've got here. How about pink? That ought to work. All right, the measure of angle XZY is going to be this angle right here. Now, how are we going to find it? Well, we now have enough information to find the measure of angle WXP that I just highlighted there in pink. All right. Hopefully these colors are working for us. Those are alternate interior angles, all right? Right there and right there. Now, how do we find out what angle WXP measures? Well, we know this whole angle here is 117, and this part on the right is 73. If you do 117 minus 73, that tells you that this is 44 degrees, which means that this will be 44 degrees down there. Again, alternate interior angles of parallel lines there are congruent to one another. All right, you've had a good set of examples as far as how you use the opposite sides and opposite angles of parallelograms and the consecutive angles of parallelograms, as well as the fact that the diagonals bisect each other in a parallelogram. Thanks for watching. Appreciate your time, guys. Later.